All right, today we're diving into a really fundamental shift in artificial intelligence, something called Agentic AI. This is where AI stops being just a simple tool that waits for our commands and starts becoming a proactive teammate, one that's capable of chasing our goals all by itself. Let's get into it. So, just imagine giving an AI a truly complex goal. Something like, hey, plan my entire 2-week vacation to Italy. I'm talking flights, hotels, activities, the whole shebang, and keep it within this budget. And then it just does it. No hand-holding, no step-by-step walkthroughs. That right there, that is the powerful idea at the heart of agentic AI. And this really is a huge paradigm shift in our whole relationship with technology. We're moving beyond thinking of AI as just some specialized tool we pull out for a single task, and we're starting to see it as a true collaborator that can manage complex projects from start to finish. This slide just nails the difference. On the left, you've got the calculator, a classic tool. Yeah, it's powerful, but it only does exactly what you tell it to do, one calculation at a time. But on the right, the agentic AI, well, it's more like a virtual financial analyst. You don't feed it equations, you give it a goal, like optimize my portfolio for long-term growth, and it figures out the entire how on its own. And this timeline shows you how we even got here. We started way back in the 80s with these super rigid, rule-based systems. Then we evolved to the learning agents we're all familiar with today. Think about your Netflix algorithm that adapts to what you watch. And now we're here at Agentic AI, which can autonomously go after goals. It's just a massive, massive leap forward. So what really makes this agentic leap so different? I mean, this isn't just a faster version of what we had before. Let's break down the key characteristics that really set this new kind of AI apart from everything that's come before it. Okay, here's the core of it. It's about being autonomous, creating multi-step plans, and this is the crucial part, executing actions. It's the difference between an AI that can only suggest a travel itinerary and one that can actually go and book the flights and hotels for you. It's not just thinking, it's doing. This analogy from the source material is perfect. Traditional software is like a printed list of directions from MapQuest. If a road is closed, well, you're stuck. But agentic AI, it's like a live GPS. It sees the roadblock, it understands your goal is still to get to your destination, and it dynamically reroutes you. It adapts. So, when you boil it all down, agentic AI basically has 4 key superpowers. It's autonomous, which means it doesn't need constant babysitting. It's goal-directed, you just give it the what, and it figures out the how. It can use tools, connecting to other apps and APIs to actually get things done in the real world. And it's adaptable, so it can change its plan on the fly when new info comes in. So how do these systems actually think and operate to achieve these goals? It's not magic. It's this really powerful, continuous process that the source material calls a cognitive loop. Let's take a look at how that loop actually works. At the absolute heart of this loop are large language models, or LLMs. You can think of them as the agent's brain. They provide all the sophisticated reasoning, the language understanding, and the planning power that makes this entire agentic leap possible. They're the cognitive engine driving the whole thing. And that engine runs on a constant cycle. First, it perceives the situation by gathering data. Then it plans. It breaks the main goal down into a bunch of logical steps. Then it acts on one of those steps, maybe by using a tool like a web browser or an API. And finally, and this part is key, it learns. It observes the result of its action and refines the plan. This loop just repeats over and over until the goal is finally achieved. Okay, but as with any technology this powerful, there's a flip side. It comes with a massive upside and some really, really serious new challenges. So now we've got to look at that difficult balance between the promise and the peril. I mean, the opportunities here are genuinely massive. We're talking about everything from autonomous scientific discovery to complete end-to-end automation for businesses. But the risks are just as profound. A major concern is something called emergent goal misalignment, which is just a clean way of saying the agent pursues the goal you gave it in a way that has unforeseen and maybe even harmful consequences. And this quote, wow, it gets right to the heart of the risk. When an autonomous system causes real-world harm, who's to blame? The source material brings up this really chilling concept, the moral crumple zone. It's this legal and ethical black hole where accountability just seems to disappear. So, this brings us to the final and maybe the most critical question we face with this technology. How do we actually control these powerful, autonomous systems to make sure they're both effective and safe for everyone. Look, the hard reality is that our old rulebooks are obsolete. Regulations that were designed for predictable, static software are just useless against these dynamic learning systems. And this creates a huge governance gap that we have to close, and we have to close it fast. And that leaves us with the ultimate question. When an autonomous agent makes a mistake that causes real harm, who is truly accountable? Is it the developer who wrote the code, the company that deployed the system, or maybe the user who gave it the initial goal? This isn't just a technical problem anymore. It's one of the most significant societal challenges we are going to face in the coming years.